1085 minus 10.85. Gotta make sure that the bit doesn't bottom out. So let's see the boreholes. What's the depth on the boreholes? I don't know if I can't remember if they're. $10.21. Gotta make sure the bit doesn't go below. Let's see. Thread mill, edit. This should be minus 0.20. Now if we see where it goes down to, it should go down $10.535. Alright, so top height from there, whole bottom. Let's put in 1 millimeter. If I can see, I can't remember if it's a negative or positive. It's got to be. Oh, that should be it, I think. Yeah, 921. The hole is 1021. So to give a millimeter clearance. That way I don't smash the thread mill into the bottom of the hole. That should still give it more than enough bite at 10 millimeters. Okay. So I got the hole bore, which is M3 or M4, excuse me. This is the M4 holes. This would be M4 threads. Now let's see, we're going to do adaptive for this big channel. So we will go 3D adaptive clearing. We'll choose a 1/4 inch end mill, single flute, 10,000 RPMs, no flood. Oh. Selection. There we go. Model selected in here. No service radial axles. I don't need. Ignore stock less than 0.1. No offsets. Retraction heights 5 and 3. Maximum roughing step down. I'm going to put 1.5 for load. Minimum cutting radius will be half of the bit, which should be, or the minimum would be half of a half. Call it 1.5. Could do both ways. 1,000 millimeters. Maximum roughing step down. No stock to leave. We'll set this to 12 since the piece isn't any bigger than 12. Horizontal lead in. 0.5. Ramp clearance. I only want this at 1.5. We'll do 0.5. Clearance height 2.0 would be fine. Alright, let's see what that shows. Let's simulate this. I think it's only grabbing about a millimeter out. Let's see, what's the depth it's doing? It's going down 10 millimeters. I think I need to raise this. It only needs to be 8 millimeters deep. The original design for this was a 15 millimeter piece of acrylic on both sides. So what I'm going to do is probably reduce this by 2 millimeters on both of them. This is one design here, and then the other design is here. This should also be, I think this one's 10 millimeters too. No, this one's less where the pump is. This one I won't have to worry too much. These are probably 10 too, or these are probably 7.5. These are 5.5 depths, and this one is 7.5. That'll be alright. So the main hole, or the main water channel, doesn't need to be that deep. I don't want this to be too thin. This is only going to be 2 millimeters if I go all that depth. Let's see what these are. Are these still like 5.5? Yeah, these are 5 millimeters. These are okay. So we're going to go back to the design. And hit extrude. And we'll add 2 millimeters. Join one-sided. That should be okay. Now if we do a measurement, eight millimeters. Actually, we'll want to give it any more. That should be good. Now we'll go back to manufacture. Probably have to recalculate it or regenerate it. And this one is going to be different. Boundary selections are missing because we changed that. So if we go here, hit the face contour and just select it again. And that should fix it. Let it do its little thing. We'll do a simulation. And this should now only be going to 8 millimeters. That's better. So far we got the M4 holes, the M4 threads, and we got the large channel. Now we have to do the smaller channels. We'll just do a basic 2D contour or 2D pocket for these. We'll select this one, and this one here. We'll adjust the retraction distance, and retraction clearance height and retraction distance. This one we're going to do multiple depths. The roughing step down, I only want to go, we'll call it 2 millimeters. We don't want stock to leave on. Finishing pass, we'll do one finishing step down, 2 finishing passes. We'll do a small step over 1.1 millimeter. Finishing overlap. Step down. I'm not going to do lead in. Let's make sure I select the right bit. 1/4 inch. These are right. Hit OK. Oh, feed rate height. I must have hit something wrong. Yeah, this has got to be. You can never have a lower number. It can be equal to, but it can't be lower. So let's simulate this. Let's see if we slow it down. Let's see if we can see the finishing pass in here. Yeah, that's the finishing pass, which would make it a little bit cleaner. Okay. So let's see, we'll rename this to LG water channel. And this one here to small water channel. So the M4 holes to threads, large water channel, and a small water channel. We still have to do the O-ring slot and the G1/4 threads in here. So seeing this is already going to be cut out, we should be able to start at the lower depth. So if we go to a 2D bore, we can use the 1/4 inch mill for the, or 1/4 inch. We'll select here and here. Set these retraction heights. And let's see, top height is not the whole, well, it might be the whole top on this, the way the design is. We'll check it to see if it simulates by going all the way up to where the original stock was, or if it goes down into the channel. So let's see. No, it goes right where it's supposed to. I gotta check that. I don't know if that's because of the hole or not. Let me see here. We'll rename this first to G1/4 holes. Let's see, we'll simulate everything. It doesn't matter, let's see what it does. On your screen it might just bypass everything that it's showing because of the frames and everything. Alright, it's still leaving this little corner here. Wonder why it's leaving that corner. So let's see, we'll go to large water channel. That's why right here. Something to do with the setup. Let's see here. Machine boundary by selection. Let's see if it changes anything with that. Well, that just cleared out those two. So let's see if we do silhouette. Let's see what it shows. Does it do that corner or no? No, it doesn't. So we gotta choose a selection. Can't do closed chain here. We could do a chain. Yeah, we can. Oh, let's try face contour. See if it does it by this face. I really can't do it by face. It's probably still going to leave that. Yeah, see, it still left it. I'm going to have to do it differently. Can't remember how I had to do this to get it. Boundary box. Let's see if it changes anything with that. Okay, it looks like it fixed it. Let's simulate it to see. Oh, no. Zoomed in too far. Alright, hold on a second here. Is this all one part? It's doing all that. Ah, with the boundary box. Let me see, I'm going to delete this. Large model channel, that. Now, what's it doing when it gets to the holes? It should be okay doing it that way. I just gotta make sure I'm not taking off too much at a time. Stressing the bit out, so minimum cutting radius should be actually be 0.5. Maximum roughing step down. That's set there because of the height, but it doesn't matter anyway because the piece is only 12 millimeters thick. Optimal load the other way. I think 1.2 was the setting I used before. We'll do 1.2. Maximum stay down, minimum stay down 1 millimeter. Horizontal lead in and out. Helix is 2 millimeter. We'll do 1.2. Minimum ramp diameter 2.5. Ramp clearance height angle. It might take a little bit longer, but okay, we got the distro plate. This is the middle panel. The only thing left we have to do is the G-quarter. I mean, if the water channel does the holes anyway, we don't need this one, so we'll delete that one. Now we have to go to threading. So we'll do threads and select the G1/4 thread mill. Can't remember if it's, I think this is it. Thread mill from Harvey Tool. That's an M4. That should, let's see, what's this one? That's M4 thread. I think this is it. I have to look. I have to look at my other design just to see what it, if I still have it, what I used. Open this one up. Edit. Harvey 71050. 71050. So thread, and let's see, let's select 71050. Select that one. I don't know why the Harvey Tools comes in with no speeds and feeds. It always does this though. Let's see, we'll go 10,000 spindle. Cutting feed rate is, for the threading, is usually 600. Plunge feed rate I usually do 150. I know I usually do, I think it's 300 and 150 for the plunge. Yeah, 6.3 and 150. That should be all right. Now we select these two faces, same diameters. Only need this at 5 and this at 3. Simulate this. Oh, I gotta set that properly. So for the holes, G1/4 threads, we have to have 1.3 pitch, 1.4 pitch diameter. So 1.3, 1.4. So go here. Otherwise it won't even make the threads. 1.3 and 1.4. Hit OK. Let's see. G1/4 threads. I think that's all that needs to be set. Multiple passes, yes. 0 degree. 2 step overs. Okay. Multiple passes. Was that step over 1 degree? Oh, 001. That's the other thing that needs to be changed. Little things that they don't tell you when you're making threads or using thread mills. Zero 0.01. Let's see, we'll simulate this one. Yeah, see, you can see the difference when it makes the threads. If you don't have the pitch, angle, and that set properly, those usually have to do tests for. These here, some information comes from Amazon and that when you buy the thread mills, or they'll give you these pitch, but more than likely you're going to have to do some kind of test. These are the G1/4 threads. I figured at 1.3 and 1.4 give me nice tight threads. We do have to see what is it going to for the depth. Same thing we did the offset. We don't want the bit coming into the spoil board and hitting the bottom. So let's see what the maximum. It's going to 12.5. We really don't want it going all the way through. We need to at least subtract 1 millimeter off of it. So we'll change the offset on this one, which should be here. Top height, whole top, whole bottom, and we'll take off 1 millimeter. Now when we do simulation, we should see that it only goes to 1150 instead of 1250. That way the tool doesn't bottom out. And that should be it for that. So we will name this. This is the G1/4 threads. And the last thing we have to do is the channels, which is the O-ring channel. So, alright, I'm going to leave this like this. I'll show just what the distro looks like when it's finished. It'll look like this. You got your pump holder and the main piece back, which holds the pump, then the front piece, and then this is an extra piece that allows it to be held to the case. I'm probably going to use black acrylic for this, with a cutout for the front, so it'll be cut out. You can still see all this stuff here, but it'll have a design here. I'll do some laser cutting or something, something crazy like a splash scene or something, maybe around this part, unless I just do a square border, which is similar to this. This also helps diffuse the RGB lights. Usually the RGB lights are put right here, so the RGB shines through the whole distro, these two bottom panels. So this being black on the front will help it diffuse so that you won't be able to see it. It'll just shine straight up through, from the top and bottom. And these are all the inlets they have for the, comes from the pump and then goes out with one to usually a radiator, and it comes from the radiator to like it'll go to like the GPU, and from the GPU it'll come in here, come back out from the GPU, and then back over to the in from the GPU, out to the CPU, back in, and then this is the other one that goes to the other radiator. I mean, there's a whole bunch of different types of distros that they have. But it'd be similar to, let's see, this one has 1, 2, 3, 4, 5 entries, which is similar to this one. Let's see, I'll do a little snipping tool so I can show what I'm talking about. Similar to this, similar to something like that. And if you notice, it has inlets and outlets. My case is a little larger than this, but you get the idea. So let me see, we're going to go back to this design. Now the O-ring channels, those are done a specific way. You have to select them. You do a 2D contour, and you have to select the proper faces. I use a 1.5 millimeter end mill, which is like a 16th, but it's a 1.5. Disable this, and on the ends that you select, you have to select this one first, then this one, then this one, and this one. And if you've done it correctly, let's just test that out. No lead in, no lead out. Multiple depths, yes. These are the most important things, so I usually like going slow through these. So let's see, multiple depths here. Multiple depths. Maximum roughing step down, we're probably going to do 0.25, I think it was. Let's see, we'll do the whole thread test. I don't need that one up anymore, or that one. So let's check this one. For this 1.25 bit. 8150 was good. What were the step downs? 0.512. Let's see. We're gonna copy it and see if we can paste. I want to repeat. Paste. Now the only difference with this is we have to edit it, get rid of these closed channels. Everything's correct here. And let's see if we select these properly. And that's better. And let's see, we'll simulate this. Usually cuts the inside edge and then comes back through and cuts the outside edge. There's not really the depth of this is like 1.3 millimeters deep by 1.2 wide for the standard O-ring. I think that's what it is, if I can remember. Let me look. It's 2.2 wide, excuse me. 2.2 wide by 1.3 deep. And that's a standard O-ring that you can get even on Amazon. You can buy the O-ring by the foot, and it fits in there perfectly. And we will just select the other groups in this by going here and do the same thing. Top one, bottom one, top one, and bottom one. Top, oh, no. Top, what, no, we want to cancel that. Cancel. Close that. And we just have this one left. Top and bottom, and top and bottom. And that takes care of all the O-ring channels. So let's see here, we'll go and simulate it. Check everything out. These are the holes. There's the threads for the M4s. This be the G1/4 threads through holes. I do have to check the size of those. This design to see if they were proper, because the G1/4 threads, speaking of that, before I forget, normal G1/4 threads, the hole has to be 11.8 to be proper for tapping with G1/4, and I never checked that on this one. Not that it should be any different, but a lot of the things in these holes weren't proper. So let's check. We'll make sure if this is 11.6. That's a little bit under, but 0.20. It should be okay. The 0.20 is going to matter that much. It just might be a little bit tighter tolerance. We'll check this one over here. Yeah, they're both 1160. I like to usually keep them 1180, but that should be okay. And that's one part of the distro finished. Now with the NymoLabs CNC machine I have with the auto tool changer, I should be able to get this done in between the single operation. Make sure that my tools are correct. T1 is going to be the 1/4 inch. T tool will be the 1/8 inch bit. T3 will be the M4 threads. This should be tool 4 and 5. So we edit the tool, we go to the post processor, and this should be 4. Did it register that? No. There we go, 4. So that's tool 4. And the last one, the O-ring, this should be tool 5. I have 6 spaces on the auto tool changer, so I could run one more tool if I needed to. There's no chamfering really that it needs to be done on this at all. So T1 is the 1/4 inch. T2 is the M4 holes. T3 is the M4 thread bit. T4 is the G1/4, since it's going to use the 1/4 inch to make these holes. And T5 is the O-ring bit. And that should be the complete operation. I have my batch post processor on here, which processes it all with the tool change. And the I have a dust boot, automated dust boot. So if you've seen any of my other videos, you know that the dust boot will it'll go and pick up a tool, then measure it, then it'll go pick up the dust boot, then cut the part. Then when it's finished, it'll go back and drop the dust boot off, pick up the other tool, measure it, and then pick up the dust boot again to continue. I have that in edited post processor with CNCJS. Now this panel is the only panel that has to be indexed for the other side because of this hole here. Usually an easy way to get around it is to do once you cut this hole here, you index from this hole right here so that you can cut this groove on the other side without an issue. So you just basically flip the panel over, and even if it's, say I put it in the machine, it's exactly straight like this, and by chance I put it in a little bit like this, if I index with the probe to this center hole right here, it will make sure that this gets cut perfectly to this hole. So that's one way to do it. Most of these countersinks, I don't do them with the machine. You can, but it can cause a lot of havoc. You can have this whole piece finished if you don't index it properly from one side to the other, because you machine this side first, just like I did the other one, and then from there you would have to, once it cuts it totally out, and you have to flip it over, so there has to be an index point. So you either have to mark a hole here and mark a hole down here with a pin, so that when you flip it over, and the pins would be opposite each other, so these two pins, when you flip the part over like this, that those pins line up and hold this piece exactly where it was previously in the operation. There was ways to do multi-probing on some of the mills where it'll touch and probe each corner and set, but for a hobbyist machine it's not as easy. The only thing is to be able to dig this channel out here, which needs to be done. Like I said, it's pretty, they leave it pretty thin in here. If you notice that, I mean, this channel here is, I think if I'm not mistaken, let's see. Oh, can't close that. I just want to know what the thickness of this is. Here to here. That's only 0.5. I got to check the original design. Because these were 15mm panels and I've shrunk them down to 12.5, I think it might have lost some thickness in there, and I might have to go through and extrude up some. Let's see what this O-ring too. This is usually a different O-ring that comes with the D5 pump. This O-ring is supposed to be, I gotta lower my settings on the mouse. That's what the problem was. There we go. This one's 240. It's probably a little bit bigger O-ring than what I have. But like I said, they usually come with the pumps. So let's measure this to there. Radius. Z position center. I don't care about the radius. I want to know the thickness. Inspect. Why isn't that showing me the stupid thing? Measure from there to here. 3.923. So yeah, it's a little bit larger O-ring on this one. Well, like I said, that comes with the D5. I'm going to check on this design. If we look on this one, this is the original design, so that's what I'm going to look at. We just have to check and see what. We don't need this one, so we're going to hide this. Pin little. We don't need that one. So let's see, and this one is, that's not one, we don't want that. this is the piece here. We got the different bodies set up. This is the one we need to hide. There's the one. Now we'll see what the thickness is of this one. This is where that shelf is, where I have it so thin on the one I'm looking at. And this one is 3 millimeters. So that's 3 millimeters, and let's check the depth of this to be sure to measure. 240. So that's right with the 3 millimeters on the piece. So what that means is when I go in here, let's see, what do we want to do? We're going to have to look at it from the bottom. And we're going to have to go into the design, like so. And we're going to grab this, and we're going to hit extrude. And we're going to add 2.50 to it. And if you see now, that made this where it should be 3 millimeters. There we go. So that corrected that issue. We'll make sure this one is still 240. Yep. Alright, that corrects that problem. We can go back to manufacture and hit the default view. Little things on the designs that need to be changed. Even these holes were the wrong size originally. They were like 4 millimeters, which a 4 millimeter tap requires a 3.3 hole. They had them all set to 4 millimeters. Probably because their machine is already preset to, you know, just drill and do whatever if it's done on. So let's see, measure these holes. These should be, these are 460. Let's see, is this 462? Let's select them all. Yeah, because normally a thread for an M4 should be 4.5 millimeters. So we'll go to design, select all these. We're going to press and pull. And it should be, you see, it's 10 too big, so it should be 215, I think. No, it should actually be 225. 215. Alright, let's check this now. For 30, we need 20.20 more. So let's see here. We select them all. Hit press pull. Should be 25. 225 on that. Measure them now. And they should be at 450. So all the holes are at 450. Which means those are through holes. That way the M4s can go right through it. The other thing to check would be all these holes here. They kept these all at 1160, I think. Yeah. 60, I think. I just want to be sure. Oh, no. This one is 5 millimeters. Yeah, that's for the pump center. And that's about it. I gotta finish editing this one. But you've seen me edit this one. What it looks like running it. Drilling the holes and tapping. Then the large water channel. Holes in the O-rings. But I will be going live with a video of this being cut on the NBX-5040 within this week. I'll start this one. So till then, I'll see everybody next time.